Today we're doing probability, and this is the last class actually before the chapter competition. And the reason I'm doing probability today is because technically probability is basically counting, which we did last semester in the 14th week. So this should not be too much that is new to you. Probability is very, very similar to counting. So we're just going to go over general probability, how you do that, and problems where you have to use probability. So not just direct, what's the chance of this happening? There's like some problems where you have to use probability, but it's different. So we're going to jump into that right now. Just a reminder that Mathcounts chapter is on February 5th, which is only 5 days away. Okay, so what this means is that in these 5 days, you got to plan out what you want to do. You got to make sure that you know all your formulas. Make sure that you, I'm not going to say you memorize them. You have to memorize them, but you also have to know where you can use them and how you can use them, and you have to know where you can. You have to look at a problem and know which formulas you have to use. Okay, so that's really important. So like I said, like compile a folder or a notebook full of the formulas and just review that for the next 5 days. Okay, and also keep doing problems. Keep doing problems and like do the homeworks. There's a lot of resources on AOPS as well. So go over all these problems. So you got to keep your mind running. You don't want to like slack off and relax before the competition. Not necessarily, but you don't want to overwork yourself. That's what I'm saying. But you still got to do problems. You got to keep your mind working. Okay. So today's topics are, we're going to go over the standard probability procedure. We're going to do complementary probability, geometric probability, and expected value. So basically the first one is all that's new. All the rest are just applications of the first one, okay? So today's mostly a review of counting, actually. Review of the procedure you would use for counting. So this is like, just like the 3 weeks we did before as review. So the standard probability technique is that you multiply probabilities and then you correct your answer. But this sometimes it doesn't work, but most of the time it does. So let's look at this example. There are 3 blue cubes and 1 red cube in a bag. You pick out 4 at random, 1 at a time with replacement, which means that with replacement means that after you pull one out, you're going to put it back in. Okay. So that's basically, you pull it out and you put it back in, and you pick all the 4 like that. Okay. So every time you pick, there's going to be 3 blue cubes and 1 red cube existing in the bag. So after you pick those 4, what's the chance that you've picked 3 blue cubes in total and 1 red cube in total? Well, let's first take a scenario where I first take 3 blue cubes and I take 1 red cube. So what's the chance of this happening? Well, the probability of this happening, the first scenario, I got a blue. Well, I have 3 out of 4 cubes that are blue. That's just 3/4. The next scenario, oh, still 3/4. Still 3/4, and we just multiply them like this. And 1 red cube, that's 1/4 probability. So this is the chance that this specific order happens. Blue, 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 and then red. But we could also have red, blue, blue, blue. We could have blue, red, blue, blue. We could have blue, blue, red, 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 blue, right? We can arrange these in multiple ways. And each of these have the same probability as this happening because there's 3 blues. Each of those blues have a 3/4 chance of happening, and there's 1 red, and each red has 1/4 chance of happening. So we have lots of these arrangements that have the same probability as happening. So we just need to multiply this value to fix our answer. This is the part about correcting our answer. To fix this answer, we have to multiply by the number of combinations or number of orders of red and blue balls, cubes we can have. So what are the orders? How many orders are there? Any ideas? What will we do here? I could always write all of them out. Right? So I could write them out. Or more efficiently is I could recognize that I have 4 spaces if I choose where the red one goes, all the rest of the spaces are going to be blue for sure, right? And I have 4 choices to choose where the red one goes. So I have 4 ways to arrange 3 blues and 1 red, okay? Because that's 4 choose 1. Out of these 4, I chose one of the spots to put the red in, and that determines the number of different arrangements of blue and red I can have. Okay, so I multiplied by 4 choose 1 to correct my answer. 4 choose 1 is just 4. 4, these cancel. And the end result is 27 over 64. And that's the probability. Okay, any questions here? All right. Here's some problems. So here are 2 examples where you have to use the probability technique I showed you in last semester, which is sometimes the standard technique I told you earlier doesn't work. And these are 2 problems where it doesn't work. So you got to use the technique I told you last semester, where you have to count the number of successes over the number of total. So here you got to use this formula instead of that one. I'll give you 4 minutes. So I'll go through these now. The first one, what's the chance that you roll a sum of 10 after rolling 2 dice? Well, to find the probability, we got to do success over number of total. What are the total combinations of numbers we can roll if we roll 2 dice? Well, I can roll 1 out of any of the 6 numbers for the first dice and any of the 6 numbers for the second dice. So I have 6 times 6 here. What about number of successes? How many ways can I roll a sum of 10 with 2 dice? Well, I can have 4 and then 6. I could roll a 5 and a 5. Or I could roll a 6 and a 4. Okay? So I have these 3 possibilities, which means I literally just count them. 1, 2, 3. 3 out of 36, which is 112. Next one is very similar. Number of success or number of total. Well, number of total, I've got 3 dice now, and each of them can be one of the 6 numbers. So you got 6 times 6 times 6. Number of successes, we can just list the number of the possibilities out again. We're gonna have 5, 6, 6, or we could have 6, 5, 6, or we could have 6, 6, 5. So actually you have 3 here. These will cancel. 1 over 72. Any questions? All good? Cool. Now these are problems where you can use your standard probability technique. I'll give you guys 3 minutes. Okay, so I'm going to go through these now. I flip a coin 5 times. What's the chance I get 3 heads and 2 tails? Well, let's just assume I got 3 heads first and then 2 tails. The chance of me getting a head is 1/2. 1/2. 1/2. Still 1/2. 1/2. That's 1/32. Okay. But there's many ways I can get 3 heads and 2 tails. I don't have to get 3 heads first and then 2 tails. I can get 2 tails first and then 3 heads. So how many ways can I have 3 heads and 2 tails? Well, I have 5 spaces. I can either choose 3 spaces for the heads. Right, so that would be 5 choose 3. Right, if I choose 3 spaces for the heads, oh look, the tails will fall in line. So I have 5 choose 3 ways of doing this. Alternatively, I could just choose the tails first. I have 5 spots, I can choose 2 out of them. 5 choose 2. And the cool thing is that these two are actually equal. 5 choose 3 is 5 choose 2. You can try to show that to yourself by multiplying it out. But anyway, it works. 5 choose 3 or 5 choose 2. I actually like 5 choose 2 better because you have to do less math. So I do 1/32 times 5 choose 2. What is 5 choose 2? Well, I do 5 times 4. So I do 5 and I multiply down for 2 integers. So I do 5 and I multiply by 4. Now I have 2, I'll stop. And then I do divide by 2 factorial. 2 factorial is just 2 times 1. So 5 choose 2 is just 10. So this goes here. I'll cancel this, 5. I got 5/4 twos, which is 5/16. The second one, if I roll a dice 2 times, what's the chance that the rolls are different? Well, let's just assume I chose 1 for the first one. I rolled a 1 for the first roll, okay? So what's the chance that the rolls are different, which means the roll is now not a 1? Well, I can have 2, 3, 4, 5, 6, which is 5 choices out of 6. So the chance that the rolls are different now is 5/6, right? So basically, if I chose 1 as my first roll, then the chance that the rolls are different is 5/6. Let me see here. The chance that the rolls are different is 5/6. Wait, I made a mistake here. So if I roll a dice 2 times, what's the chance that the rolls are different? Well, alternatively, what we can do is we can do what's the chance that the rolls are the same, right? The chance that the rolls are same is 1/6 times 1/6. Oh, I actually did not make a mistake. Sorry. So what's the chance that the rolls are different? If I chose a 1, then the chance that the rolls are different is 5/6, right? But the chance that I rolled a 1 is 1/6, right? I'm relying on the fact that I chose a 1 first, which means that the chance that I got a 1 and the rolls are different is 1/6 times 5/6, okay? Because I first had to choose a 1, which is 1/6, and then I had to make sure the second one was not the same as the first. So I had 1/6 times 5/6. But I could have chose a 2 for the first one. I could have chose a 3, a 4, 5, or even a 6. I could have chose any one of these 6 numbers to be the first number. So there are 6 ways I can do this. So these 6's actually cancel out. All we have left is 5/6. All right. Any questions here? Cool. So I was actually hinting at what we're going to do now, which is complementary probability, which is nothing new. It's a new type of solving probability. So you're going to use this technique whenever the problem says, what is the chance that at least, and it's going to say something after that. So as an example, what's the chance that at least one roll of 3 gives, what's the chance that if you roll a dice 3 times, what's the chance that at least one of them gets a 4? So how you solve this? There are actually 2 ways. The first way you can solve, first you can do casework. You can do casework now because the first case is that you get exactly 1 4. The second case is you get exactly 2 4s. The third case is you get exactly 3 4s. If you calculate the probability for each of these and add them together, you'll get the answer. But you've got to do 3 cases here, which is a lot of work. You could do that, but the smarter way to do it is actually complementary probability. This relies on the fact that if you add up all the probabilities, you'll get 1, right? So we can actually find that what's the chance that 0 rolls gives a 4. So what's the chance that none of them is a 4? If we find the chance that none of them is a 4, let's say this is my probability. My total probability is 1. Let's say this is the chance that I get none out of 4. None is a 4. Okay, none is a 4. None of the rolls is a 4. Well, the rest of it must have something, right? It must have a 4. Because if I have all my cases where there's no 4 here, then the rest of these must have at least one roll as a 4. Right? So if I find the probability that none is 4 and I subtract it from 1, then I get the probability that at least 1 is 4. So what's the chance that none of them is 4? Well, that means for all 3 choices, all 3 rolls, I did not get a 4. There's a 5/6 chance for each of those. Okay? And multiply, that's pretty big, 125 over 216. You subtract out that 1, you get, let's see here, quick math. I think that is 91. Just doing it in my mind here, it might be wrong. Okay, do you guys get the idea then? So basically, if we have a problem where it says, what's the chance that at least something, then you find the probability that none of it is true, which is here, and you subtract that from 1 to get the actual answer. These are all problems we can use complementary probability. Okay, so the first one, flip a coin 4 times. What's the chance I get at least one head? Well, whenever I see the word at least, it means I have to do complementary counting. I will find the chance that I get 0 heads, and I do 1 minus that. So what's the chance that I get 0 heads? Well, that means that I don't get a head for all 4 times, which means I get a tail every single time, which means it's a 1 over 2 to the 4th chance of that happening. And the reason I don't correct for my answer is that there's only one way you can get 4 tails, right? There's only one way you can get all tails. So basically, there's only one way that you can do this. So if I were to correct my answer, I would just multiply by 1, which does absolutely nothing. So basically, that's why I didn't correct for my answer. So the chance that I get 0 heads is 1 over 2 to the 4th. To get the chance that I get at least 1 head is 1 minus that, which is 1 minus 1/16, which is 15 over 16. That's the answer, okay? The next one, 10 red balls, 15 orange balls. You pick out 5 without replacement, which means that you're not going to put them back in. So what's the chance that you get at least 1 red ball? Well, what's the chance that I get 0 red balls, right? If I get 0 red balls and I subtract the probability of that happening from 1, I'll get the answer. So what's the chance I get at 0? 0 red balls. That means I got orange balls every single time. The first time, the chance I get an orange ball is 15 over 25. There's 15 orange balls out of 25 as total. I'm not replacing them, which means now there are 14 orange balls and 10 red balls, which means the chance is now 14 over 24. Right? I've taken 1 orange ball out. Now I only have 14 left, and there are 24 total now. Now I only have 13. Right? I only have 13 orange balls, which means now the probability is this. I do this 5 times. And this is the chance that I get 0 red balls. Well, I can simplify a lot of this. I'm going to cancel, okay, 2, and then we got 12 and 24 are canceling. 2 down here, 24 and 11 are canceling, got 3. 15 and 25 are canceling, got 3 and 5. These 3's cancel. Oh god, these 2's cancel. So it seems like all we have left is 13 over 5 times 2 times 23, which is 230. This is the chance I get 0 red balls. So don't put this in right now, okay? A common mistake that you do when you do complementary probability is you find the chance to get 0 and you put that in. You have to take 1 minus that, okay? 1 minus that, you would get 200 and, let me see here. Quick maths, 217 over 230. Okay. Go on to geometric probability now. It's another probability technique. The probability of something happening is successful length, area, or volume over total length, area, or volume. So basically, that's kind of like what we're doing so far, the successful over the total. So here's an example. You pick a number on the number line that's from 0 to 5. What's the chance that the number is less than 0.5? Well, the total length in this scenario, the total length is 5. Right? I'm choosing a number between 0 and 5. What's the chance that it's less than 0.5? The chance that less than 0.5, it has to be in this region. And this is the successful length. Success. If I choose it in this region, it's a success, which means that the successful length is 0.5. So the probability is 0.5 over 5. Okay. It should be pretty simple. It involves a lot of geometry, though. You gotta remember how to do geometry. But basically, there's a lot less multiplying probabilities involved here. So you just need to find the successful length, area, volume, divide by the total length, area, volume, okay? 2 problems here. Second problem is pretty interesting. I'll put that in the homework, but we don't really have time for that now. So let's do the first one. Seems like a lot of people have gotten this already. So I'm gonna go through the answer. So Jane is randomly throwing a dart at a target. The bullseye has a radius of 1 centimeter. The entire target has a radius of 20 centimeters. What's the chance that she hits the bullseye? Kind of looks like this. This is 1 centimeter. This is 20 centimeters. The total area, so the formula is that we find the successful area and we divide by the total area. The successful area is just a circle with radius 1. 1 squared times pi. Total area, well, that's a circle with radius 20. So 20 squared. The pi's will cancel. So the probability is 1 squared over 20 squared, which is 1 over 400, which is pretty slim, which is why playing darts is hard if you don't know how to do it, if you're doing it randomly. Okay. Let's go on. Now we have another, this commonly comes up, at least like one problem for competition. It's called expected value. It's like, so the formula for expected value, I'm going to show you some examples later on. But the formula for expected value is you take scenario 1 times the probability that it happens, plus scenario 2 times the probability that it happens, scenario 3 times the probability that it happens, and you go on and on and on, and you get your expected value. This may look like nothing to you right now, but like write it down in your notebook. I'm going to go over an example on the next slide. So write it down, and you're going to see this formula in action. So yeah, so this might seem like nothing to you right now, which is totally okay. But this is the formula I'm going to use. I'm going to apply this real quick in the next slide. Okay, so you roll a dice. Okay, this is the first one. The first one is the one I'm going to demo. You roll a dice. If you roll a multiple of 3, then your friend gives you 3 goldfish. If you roll anything else, you have to give your friend 1 goldfish. You start out with 100 goldfish. After 20 rounds, what's the expected number of goldfish you have? So what's the expected number that you're going to have? So what's the most likely outcome? Not like the most likely outcome, but what's the expected one? You could win all the goldfish, you know, right? You could have rolled a multiple of 3 every single time, and that would have been great, right? But not likely. You could have rolled that not a multiple of 3 every time, and you're going to lose a ton of goldfish. But what's the expected value that you're going to get out of this? Well, the expected value is scenario 1 times the probability that it happens, plus following scenarios times the probability that it happens, and so on. So how many scenarios do we have? The first scenario is if I roll a multiple of 3, and I get 3 goldfish. I win 3 goldfish. So scenario 1 is that I get 3 goldfish plus 3. The probability that it happens is 1/3, because the chance that I get a multiple of 3 is 2 out of 6. There's 2 multiples of 3 out of the 6 numbers we have. This is the chance. This is the first one. Now scenario 2 is that I roll something else, and I have to give my friend 1 goldfish. So what's the chance that that happens? Well, scenario 2, I lose 1 goldfish, -1. I'm losing goldfish. I'm not winning anything. So the chance of scenario 2 happening is -1. And the chance that it happens is 2/3. Right? The chance that I don't roll a multiple of 3 is 2/3. So the expected value is going to be 1 minus 2/3, which is 1/3. So this is the expected value. This is the expected gain, because I'm considering the changes in the amount of goldfish I have here, right? I get +3 or -1, but this is the expected change in the number of goldfish I have. Okay, after 1 round, the expected change I have in the number of goldfish is 1/3. I gain 1/3 goldfish. That's the expected number of gain, the expected change in goldfish I have. So after 20 rounds, I have to multiply by this by 20 to get 20/3. And 20/3 is the expected change after 20 rounds. So I just need to add this to 100 now to get my final answer, which is 320/3. This is the expected number of goldfish I will have after 20 rounds. which is good for me, right? So if I were to play this game with my friend, I would do it because the expected value is that I gain a lot of goldfish, which is good, okay? So now it's your turn to find the expected value of a dice roll. When you roll a dice, what's the expected value you get? I'm going to work on this until the end of class, which is 2 minutes. All right, so for this problem, the expected value of a dice roll. The first scenario, I get a 1. I roll a 1. Okay, so the first scenario is I roll a 1. The chance that it happens is 1/6. Second scenario is I roll a 2. The chance of that happening is 1/6. Third scenario, I roll a 3. That chance of happening is 1/6. Fourth scenario is I choose a 4. The chance of that happening is 1/6. So on. Okay, so this is the expected value. To make this process quicker, to value all these fractions, I can factor out a 1/6, and this would be 1 plus 2 plus 3 plus 4 plus 5. And what is all that? 1 plus 3, that's 21. This is 21. We cancel this, we get 2 and 7. So the expected value is 7/2, which is 3.5. This is actually the expected value of a dice roll. Okay? Any questions here? So the scenario changes. Okay. The scenario, when I did this problem, the scenario was change in number of goldfish. Okay. The scenario in this one was dice roll, the value of the roll. Okay, so the scenario changes, and you're going to have to be able to pick out what that would be for each problem. Okay, that's it. So good luck on the chapter competition for those that are doing it this week. Remember to do problems. If you have any misconceptions about geometry, number theory, algebra, any questions, just ask me through the WeChat. Okay, if you have any misconceptions, just make sure that you figure out how those work. So I'm always available on WeChat. So as you're doing problems, if you find like a concept that you're not very clear on, just chat me through the group chat and WeChat, and I will give you a response. And the internet always helps too. Okay, so you can always search the internet. All right, good luck on Friday. I'll see you next week.